Recently I heard in a video that EndFed transformers are not very efficient. In my comparison video I did between a dipole and an EndFed antenna, in the field we saw not much difference between them. They both performed very similar. So I gave it another shot and tried to measure my 1-49 transformers in the lab. I know, measured on the bench with the nano-VNA, the two transformers I usually use should be more than 90% efficient. But these are measurements with very little power. I wanted to push these transformers to its limit and see how much loss is there if I put some decent power through them. To measure this, I put always two identical 1-49 transformers together. The first one transforms the impedance to approximately 2500 ohms and then the second back to 50 ohms. The input of these two transformers will be fed with an ICOM 7300 and the output goes into a dummy load. I measure the power, what goes into the transformers and what comes out. Because I have only one external power meter and on the ICOM I can't really get an accurate reading, I first measure the output power of the ICOM externally and after that the power after the two transformers. If we then divide the measured loss in half, we should get the correct power loss of one transformer. I did this also for 4 different bands and sometimes with different power settings. You will see in the spreadsheet later. During the measurements I also checked with a thermal camera the temperature of the cores. I also tested in the end a 1-to-1 balun. That's a voltage balun what transforms a signal from unsymmetric to symmetric. It just balances the signal. Something what you should use before feeding a symmetrical antenna like a dipole from a coax cable. In the end I tried also measuring the loss of two antenna tuners to compare it with the fixed ferrite core transformers. So here are the results from the measurements. The small ferrite 264-362-5002 transformer wound with a 0.5 mm wire has an average loss of 22% or 1.1 dB. Measured first with 10 watt input and then with approximately 20 watts. The result was the same for 10 watt or 20 watt. Both average at 22% or 1.1 dB. But the cores get even with 10 watt quite hot after some minutes of transmission. So 22% or 1.1 dB for one core. I know it will not make a big difference during operation, but I just want only lose as little power as possible. If you go ultra portable, where weight is super important for you, then the small ferrite is for its size really good. Just don't use more than 10 watt for longer TX periods. Two additional things I also tried for the small ferrite core. I put the windings close together and then spreaded them more apart. There was no difference visible on the power meter. I heard also rumors that you can get sparks jumping from one winding to the next. I couldn't see that with my microscope, even if I put 70 watt for some seconds through that 0.5 mm wire on the small ferrite. Maybe it's possible with much more power, but I couldn't replicate that. Next transformer was a T3623 wound with a 1 mm thick wire. Average loss about 31% or 1.6 dB, so this core is clearly not made for that purpose. Bigger than the small ferrite, it handled more power better, but the 31% or 1.6 dB is not really good. Next was the big ferrite 26432-51002, also wound with a 1 mm wire. I fed them with about 60 watt of power and the average loss was approximately 20% per core, only 12% or 0.56 dB loss. That's awesome. From now on, that's my favorite EndFed ferrite core. I will also use this transformer portable. It's quite heavy, not super big, but I think worth it to carry, also because it handles the heat much better. That's the transformer I used on most of my field measurements in the past anyway. Survivalcomms did a very similar measurement about 2 years ago with the same core and we both got very similar results. Link is in the description. He confirmed that this core is also much better than a 240-43 ferrite core. The last core to measure was the 1-to-1 balun. Just for clarification, that's not a current joke. Because everything is today called balun, it sometimes gets confusing. This thing I measured is balancing an unbalanced signal. The cores are quite small, but the measured loss was sometimes so low that it was hard to see on the power meter. I fed them with about 60 watt of power and the average loss was only 2.6% or 0.1 dB. I'm not sure which cores are used here, but it seems like it's not critical for a 1-to-1 balun. I will check other cores in the future. The question what I have now is how small can you make such a 1-to-1 transformer what can handle 100 watts of power? Maybe iron cores are for that purpose better than ferrite cores? I don't know. If you know, please let me know in the comments. So now I know the loss of my EndFed transformers, but how about antenna tuners? I own an LDG AT200 Pro 2 auto tuner and the small ATU 10 by November 7 Delta Delta Charlie. On my last holiday I used a 10 meter long horizontal wire for the 20 meter band. That wire I could use with my EndFed 1-to-49 transformer, but also with that little ATU 10. It got it tuned. So what is more efficient? During operation I couldn't see a lot difference, but it was hard to compare because I couldn't switch fast from one to the other, and you know the band conditions always changing. So my idea to measure the efficiency of the antenna tuners was to wind two 1-to-16 transformers, because I thought 1-to-49 is maybe too much. But should transform the impedance to about 800 ohms, then measure its loss in the same way I did with the 1-to-49 transformers. At that point I know the loss of one of these 1-to-16 transformers. It was about 11% or 0.5 dB. This 1-to-16 transformer I then connected in reverse to the antenna tuner. The tuner should then match the 800 ohms and the transformer should transform it back to about 50 ohms for the dummy load. After measuring the total loss, I then subtract the loss of the 1-to-16 transformer and we should get as a result the loss of the auto tuner. With the LDG tuner I got on 80 meter only 5.1% or 0.3 dB loss, at 40 meter 9.2% or 0.5 dB, on 20 meter 15.4% or 0.9 dB, and on 10 meter 23.9% or 1.9 dB loss. With the small ATU10 I got on 80 meter 16.6% or 0.9 dB loss, and on 40 meter 19.7% or 1 dB loss. On 20 and 10 meter it not wanted to tune. So in other words, the efficiency of the big 200 watts LDG tuner is comparable with the big ferrite core. On the lower bands even a bit better. The efficiency of the small portable ATU10 tuner is comparable with the small ferrite core. That's quite impressive. That raises another question for portable use. A fixed length EndFed antenna with a 1-to-49 transformer, or would be a random wire antenna with the small ATU10 tuner even better? But that's for another video. I hope that was interesting for you. I wish you all a nice day and thanks for watching.